Welcome to day one, area of triangles and quadrilaterals. In this one we're going to talk about the formulas for the different ones, and you probably know most of these guys, so I am going to just show them to you. And so the area of a parallelogram, remember, is area equals base times height, or length times width, or whatever, however you want to remember it. And so that's our formula for a parallelogram. A triangle's formula is base times height divided by 2, because if you remember, if you have a parallelogram, well, let me try again. If you have a parallelogram of some sort, and you cut the parallelogram in half from corner to corner, you get a triangle, and so the area of any triangle is half the area of a parallelogram, and so that's where we're getting that from. So the area of a parallelogram is base times height divided by 2. The area of a rectangle, well, a rectangle is just a straightened up parallelogram, if you remember from our parallelogram, our quadrilateral unit, and so with right angles, and so it has the same formula as a parallelogram, that the area is base times height. Then we get down to a trapezoid, and a trapezoid has this crazy looking formula of 1/2 height times base 1 plus base 2. Where this comes from is it's still from a parallelogram being cut, but now the parallelogram is being cut not from corner to corner like it did in the triangle. It's actually being cut somewhere randomly in the middle, and it's still cutting it into two separate parallelograms. But if we call this one base 1 and this one base 2, you'll notice by my cut that this guy would be base 1 and this one would also be base 2. So therefore we add the two bases together, which would get us this full length, just like we're dealing with a parallelogram. So there's the base of the parallelogram times the height of the parallelogram, which would be this perpendicular distance right here. And so I could kind of draw in a perpendicular distance, and so there is the height of my parallelogram, and so there is base times height, but we only want half of it because we cut it in half, but not from corner to corner, so we cut it in half and said that that's where we're getting our area of our trapezoid from. It is 1/2 the height times base 1 plus base 2, because we're adding those two bases together to get the whole base, but we only want half of the shape, so we're dealing with a area of a trapezoid. The area of a kite is just like the area of a rhombus. The kite is diagonal times diagonal, cut in half. And so we end up, here's our kite, we take the two diagonals that we have and multiply them together. Since they are perpendicular, that's helpful for us. They are perpendicular, so we take diagonal 1, the length of that one, which would be the short one, times diagonal 2, and cut it in half. If all else fails for a kite, you could go ahead and find the area of each one of these little triangles, add them up, and you'd still have the area of the kite. And then a rhombus is the same deal as the kite. It's just that all the sides are the same, so it's the diagonal times the diagonal, cut in half. And we will talk more about these in class, but I just wanted to get these formulas out there, and so make sure that you get all of these formulas down. If you need to rewind this or pause it to get them all down, you will need them for class. So let's practice some of these. Well, here's our first one. You guys can go ahead and try it on your own, pause it and try it on your own. You'll notice that in this one I have basically two rectangles, and there's a couple ways you can go about this. I have two rectangles. I could find the area of this little rectangle, which is 4 centimeters by 4 centimeters, which is 16 centimeters squared. Up here, 8 times 12 would be 96 centimeters squared. And now I could add those two together, and so 96 centimeters squared plus 16 centimeters squared will give me 112 centimeters squared, I believe, when I add that up. And so that would be the total area. That's one way of doing it. The other way, some of you may see this, that this is a cutout from a bigger rectangle, and a rectangle of 12 by 12. And so if I did that, this side is 12, this side would also be 12, 8 plus the 4, so there's a 4, oops, there's 4 centimeters there. And so 4 centimeters right there, and so 8 times, so we'd say 12 times 12 would be the total area if this thing was all filled in, and so we'd get 144 centimeters squared, but then we got to remove this cutout, which is 4 by, looks like 8, and so 4 by 8 is 32. And so if we subtract 32 centimeters from the total area, we end up with 112 centimeters squared. So it just depends on how you see it. You need to make sure that you are figuring out the best plan of attack for you. Another one that might be helpful would be something like this. We're trying to find the area of the shaded region, so give it a pause and try it. But here's how I would do this one. I'm going to find the total area of this and then subtract away the white areas. So I'm going to say, okay, the area of the whole shape would be using my formula of base times height because it looks like a parallelogram. Then I'm going to say the area of the whole thing would be 13 by 9. Well, if I multiply that out, I get 117 centimeters squared, I believe. Let's see, let me check real quick. 90 and yeah, 117 centimeters squared, but then I have to subtract away these two shapes. Now the question is, what are these two shapes? Well, they look like, to me, parallelograms. The base is 2 and the height between the two bases is 9. So 2 by 9 is the area of one of those parallelograms, which is 18 centimeters squared, but I've got 2 of them, so I got to subtract 18 centimeters squared twice, and so then I get, when I subtract that, I get, I think, 81 centimeters squared. I believe that's the what I get for the total of that, and so that would be the total area of the shaded region, is the 81 centimeters squared. There are other ways you could have found the area of these found the area of each one of these shapes. You got a trapezoid on each end, add that up, a parallelogram in the middle, and a trapezoid. You could do that if you wanted. And so then it's just a matter of kind of messing around trying to figure out what the numbers would be. But I think that finding the area, finding the whole thing, and then subtracting away the little 2 would be your best bet in this one. And then we're trying to find the area of this shaded region, and there's a couple plans of attack for this one, but the issue is that some people see this when they look at this as these are 3 equilateral or 3 equal triangles. I'm not 100% sure that they're equal. I'm not sure that this point right here is the midpoint, so I'm not going to do that. I could find the area of one triangle and then multiply it by 2. That would work. That could work if these guys are all the same, but I don't know for sure, so I'm going to do this as a trapezoid and then subtract away the area of this little triangle in here. So I'm going to find the area of the trapezoid first, which, remember, is 1/2 the height times base 1 plus base 2. And so if I do that, 1/2 times my height, which is the distance between the parallel bases. You can see the arrows that represent that they're parallel, so the height is 4. And then base 1, which is I'm going to call the top in this case, is 12 plus 20. All right, so if I was to multiply this all out, I would end up with 64 centimeters squared if I was talking for the whole trapezoid. But I don't want the whole trapezoid. I have to find the area of the white triangle. So the area of the triangle that I need is a 12 by 4, but remember, cut it in half because it's a triangle. So 24 centimeters squared is the area of the white triangle in here. And so with that being the case, I would subtract 64. I would take 64, which is the total area of the trapezoid, and subtract away 24 centimeters, which gives me a total of 40 centimeters squared. So this is some of the stuff that we're going to be doing in class. If you have any questions, please come to class prepared to ask them. We will do more of this, but make sure that you get the formulas down.